Welcome aboard, Suri. I am going to be handing over the floor to you right now for your presentation. I'm going to be muting and hiding my camera. So please go ahead.
Thank you very much, and thank you very much for Cyber Observatory for the opportunity to present today to the audience. Let me just share my screen. Okay, so the topic for today is security done right for SecDEvOps cloud native organizations. My name is Suri Baruchai. I'm the founder and CTO of Reblaze. A little bit about Reblaze before we're going to dive into the topic. We founded the company back in 2012, serving 250 plus enterprise customers around the world, protecting nearly 50,000 web application and APIs and web services, processing dozens of billions of HTTP requests per day, and with a quite satisfied customer base. And our business is basically is involved with the topics we're going to cover today. So as we would like to discuss about cloud native DevSecOps, I thought it would be a good idea to hang on those terminologies, those terms for a few minutes, understand them and define them, and then it will be easier to discuss further advanced technologies, techniques, tips, and so on. So in a nutshell, cloud native is a set of technologies, I would say even before the technology themselves, is a set of concepts that when applied, basically can be applied anywhere you run your computing, whether you're running on a public cloud, on a private cloud, or on-prem. You deploy your computing, you deploy your services in a way of which you take into account that the environment is dynamic, the environment is defined as code, as also known as infrastructure as code. And the best way to describe those technologies, or to demonstrate those technologies, is basically looking at containers, microservices, serverless functions, and so on. Those are basically examples of implementation of cloud native. If you put them together, you take containers together with serverless functions and microservices, you put them together, you get a powerful infrastructure of which you can deploy and manage high-scaled environments, ensuring uptime, security, all along the way. And the bit about those technologies, and there's a Cloud Native Computing Foundation, which we are a proud member of, is all about making sure the technology stack, the tech stack you choose is vendor agnostic. Is not bound to a specific vendor, to a specific cloud vendor, or a specific company, or it's open technology that anyone can use, apply, and implement anywhere they're running. Hybrid, private, public, combination of all. So for cloud native, when we talk about SecDEvOps, so I would say Sec is an extension to DevOps, which basically became a term as cloud native, along with cloud native technologies and stack. When we define infrastructure as code, then we have the teams and the framework of which you write code that defines infrastructure. Infrastructure as code, in most of the cases, people tend to think about it as a way to automate deployment, provisioning, and so on, to achieve efficiency, to save time, and so on and so forth. But in fact, infrastructure as code is a key foundation for organization to achieve a better secured infrastructure. And I will explain why. When an infrastructure is deployed manually, meaning sysadmin, an operation team is logging into a remote computer, remote server, configuring the server manually, typing commands, using UI management consoles and so on, and defining rules, policies, etc., etc. Those activities are made by human, or can be, mistakes can be made. And not only that, may not be consistent across cases, across instances, right? When your infrastructure is deployed automatically, meaning think about it, instead of sending a human to perform a task, you send a robot, a machine to perform the task. For the machine, the task is defined to the last detail, meaning you define the security rules, you define the firewall rules, access list, and so on and so forth. And anywhere infrastructure is deployed, those rules applied. There's no way of somebody decided to delay some security policy for tomorrow or I will do it later. There is no later. There's no temporary hacks and so on. Things are done as defined, and you can assure consistency and policy implementation across all your configuration and all your deployments. More than that, suppose you find that a change needs to be made from a security perspective or from any other reason, then changing it once and redeploying everything can be done automatically once you get your infrastructure as code done right, versus when ticks need to be done manually, then we have a window of vulnerability. For example, back in the day when vulnerability was discovered of a given server version or framework or language or Linux, Windows, whatsoever, when data centers were deployed manually, then you needed the team to arrange the window of updates. And if it's a large data center, then the time frame or the timeline, I would say, until you can ensure that you patch your entire infrastructure was longer than you wanted to, but you had no choice because you're dealing with production environments, and production environments, you cannot just take them down and take them up. You have to ensure uptime. Infrastructure as code enables you to ensure uptime during updates. So you create, you plan, you adapt, you respond, you configure, you reconfigure, you release new version. All those continuous processes, also known as CI/CD, continuous integration, continuous deployment. Those are the concepts that helps us also from security perspective to ensure that when a security hotfix, patch, correction need to be made, it will be done as soon as possible and across the board, end to end. So today what I'd like to do is talk about one of the ways organizations have chosen to deploy the infrastructure in the cloud, and that one also goes by the name of Service Mesh. Service Mesh is all over the place. There is I think the most popular one is Istio, started by Google, an open source project. There is another quite popular one named Linkerd. Microsoft just started one by the name of Open Service Mesh. But they all came to provide three I would say, three capabilities, three functions to the site reliability engineers, to the DevOps engineers, or to the organization. Within the service mesh, you have definition of data plane and the control plane. The data plane is where the data, the application data is being managed, the proxies, the routing, the headers, the upstreams, and so on and so forth. And the control plane is where policies are being applied and implemented and controlled. So in this case, if you take Istio, for example, so at the bottom of the control plane, you can see Citadel, which takes care of TLS certificates, making sure there's mutual MTLS, mutual TLS across all the pods within the microservices, within the Kubernetes. There is the mixer, which basically does all the policy checking, telemetry, configuration, publications, and so on. And for each and every pod, you have a sidecar proxy where you can apply policies for data, application policies and routing and so on, and perhaps even security policies. And I will demonstrate that one in a few minutes. So same concept, service mesh is basically saying you have dozens of services, microservices, and you want to put them all together to play nicely within the Kubernetes. Service mesh is a layer on top of Kubernetes that will help you get everything done properly. So again, those are three different types. There are probably dozens of them right now out there, but the idea is the same. And so it seems like service mesh is, I would say, the adaptivity, the adoption is growing and become more and more popular and more the choice for organization when they reach a point of certain size, certain scale, and complexity within their deployment. Now, what I'd like to talk today is about an open source project that we have donated to the Cloud Native Computing Foundation in the beginning of this year. Project of which provide you, the organization, which suppose you're in charge within the organization, in the security, in the operations. You're in charge in their day-to-day operations, cloud operations. So provide a set of tools packed as a product, free, it's open source, that helps on a day-to-day security and protection against all sort of attacks that might be coming to your platform from a variety of, I would say, orientations and reasons. So what we see here, I would say, is a typical deployment. In this deployment, we can see we picked, in this case, Envoy proxy as an ingress gateway, where the users are communicating with the ingress gateway before reaching out to a web service or web services. So that project here, fans, provides you with all the capabilities, with all the tools that you will need to profile sessions, to control what is legitimate and what is non-legitimate, to, I would say, to easily implement a web application firewall that will protect against all sort of SQL injection and CSS attacks and request forgery and all sort of remote file inclusion, always top 10, always top 10, 20. It also provides the ability to protect against bots, unwanted bots in that case. And obviously, given the scalability of the cloud and the bot management and the bot detection and so on, it provides layer 7 DDoS protection. And I would like to dive in a little bit, feature by feature, capability by capability, just to make sure we cover all aspects of, and simply exposing us to potential risks, potential attacks that every web service need to protect themselves against. The system itself is operating in multiple layers, meaning when a request is received on a proxy, whether as an ingress gateway at the beginning, at the entry point of the service mesh, or whether it was deployed as a sidecar on the pod where the web service is running, the request is arrived, the system runs multiple different mechanisms, which starts with the profiling. Profiling is the foundation of all the following processes in which the request is arrived, and that will be demoed shortly. Request arrived based on content of the request, based on the source of the request, whether the IP or the S number matching with existing databases the system is integrated with. The request is tagged in a certain way. Maybe tagged as VPN plus bot plus, I would say, scanning tool, right? So those simply ranking each and every request on a request level, and at the same time on the session level. Session is basically a sequence of request and response over time, over a timeline that represents either an API session or user session with application or service. So on top of it, there is an advanced rate limiting, which provides the user with the ability to limit requests. For example, if you take the classic login operation. So suppose within your organization, there is a login operation that happens against an API, the authentication API server. So classic rate limiting, I would say, would let you limit the number of login actions can be taken from a given IP within a given time frame. A bit more advanced rate systems will provide you with the capability of limiting not only based on IP address, which in many cases can be shared amongst multiple users. For example, mobile carriers, they may share same IP across hundreds, if not thousands of users. So rate limiting in some more advanced systems can be also implemented and applied on the user ID, the login ID, for example, session ID, and so on and so forth. However, carrier fence provides further more than that. And I will show you. Not only that you can limit based on IP or any other element within the layer 7, such as user ID, header, cookie, or argument within the request body, carrier fence lets you limit how distributed a session can be or allowed to be within the context of your service. For example, when carrier fence detects that a given ID is being submitted login requests and attempts from multiple IPs within a given time frame, that may raise a flag. Why would same identity be accessed across multiple different IPs within relatively short time frame? More than that, if it's not just multiple IPs, different IPs, rather different geolocations, different countries, different cities, why would a legitimate user will hop from within, say, 5-10 minutes. Try to log in from the UK, then Australia, then Singapore, then China, then United States or Canada, for example. Usually those type of activities suggest distributed brute force logging or account takeover attempts, distributed bot attacks. And the reason the IPs are roaming and rotated for each and every request is to cope with legacy systems of which counting, rate limiting per IP. So in that case, as I said, Caref has provided the ability also to detect and block those type of activities. Then static filtering is another layer that goes into the actual content of the request, looking into the headers, looking into the cookies, looking into the payload, into the URL, and matching them with signatures, with existing rules. Those are the static filtering. Done, all is good, request is passed, suspicious, request is blocked or may not be blocked, but indeed marked as suspicious. At that time, while the request is being served, the request data, the metadata, all the information about the event is submitted to data warehouse database, Elasticsearch, Google BigQuery, DynamoDB, and so on. You can choose the database of your choice. In addition to the database, also Caref sends metrics, all sort of metrics to Prometheus database. So easily we can look into and analyze recent events within the system, say last minutes, last 5 minutes, last 30 minutes, and so on, and easily detect anomalies, easily detect malicious activity, malicious sources, and perform an escalated reaction, an escalated security measure against those sources dynamically and automatically. So this is the concept of the system, and this is how the system actually works and the tools it provides. Now, we're not just talking about security, we're talking about security in a cloud native organization. Given within the cloud native organization, infrastructure is deployed as code. Infrastructure is deployed within automatic process. Caref was built with that mindset. It's API driven. Every operation can be done either by the API or using the portal. It has Git operations at core, meaning every change you made, or you can define different type of branches and different type of configuration and policies for the QA, for production, for staging, for testing, and manage them and switch between them and control what policies will go to which environment automatically. That's the beauty of the GitOps, which is, I would say, an evolution of the DevOps, meaning the configuration files, the policies, and the infrastructure as code is derived from a Git storage, which Git, for those who are not familiar, are the most popular configuration management system. And with the principle of simple I/O, simple input and output. And what do I mean by that? Given no application is an island and no solution is working on its own, we had to make sure it will be easy for our users to integrate with our system, to provide input, to configure the system with policies and configuration, as well as to receive outputs in a form of metrics and logs and so on. One of the beauties of Fence, which we added in the recent weeks, is providing quite, I would say, advanced web client authentication. Whether we're talking about web browser, desktop, laptop, or mobile browser, or even if we're talking about mobile native application. Fence comes with an SDK for mobile native applications, iOS and Android, and with built-in JavaScript plugin that you can easily plug into your web applications. And in that case, Fence will do a far better job on detecting humans, which then will be used to tell apart humans and bots and treat each and every case separately. Just for your information, we replaced the creators of Fence, but we didn't do it alone. We worked together all along the way since the beginning of previous year with teams and companies such as Airbus, eBay, Cisco, Lyft, obviously the creators of Envoy Proxy and Red Hat. And as I mentioned, member of the Cloud Native Computing Foundation, our company Reblaze is a member of the Cloud Native Computing Foundation. And the project is also sandboxed right now within the CNCF. So that's it, I would say, for now in terms of slides. And at this point of time, I would love to jump into a live demo, provide you just a little bit of, so you can taste what Fence actually provides the user. Okay, so starting with the Fence, I would say Fence dashboard, that's the UI. I would start with the session profiling. The capabilities, as I mentioned, of profiling and tagging each and every request based on content and sources. And what do I mean by that? For example, suppose I would love to incorporate Spamhaus. Spamhaus is a project, quite popular and highly ranked and appreciated project that simply provides an up-to-date daily basis, daily feeds of all sort of hijacked servers, IPs, NAS numbers, service of reach, distributing spam, distributing malware, Trojans, and botnet controllers. They provide their list in various formats. They got a drop list. They do not route or peer lists, list of bunch of CIDRs, CIDRs, net blocks, each of which has its own block of IPs. They provide an extended list, which has more entries in, however, most likely to contain IPs which are not that, I would say the drop list is probably more certainty, higher certainty for being malicious, while the extended list is probably a bit lower certainty. So that is the IPv4. They got the IPv6 as well as the AS numbers, right? So for example, suppose you would love to have this list incorporated in your service mesh, meaning if an IP, or in case of IP or AS number in that case, is included within this list, you would like to deny traffic from those sources. So what you would do, So we go to session profiling within Carefence. And for example, so it was a demo, for example. So let's put a tag to it and say that's tag is spam house, right? Spam house will be the tag, and block list, just as another one. And here in the source, I will simply provide the URL for the list, right? Once this is done, I can click one time. I will click on a button, update now, and Carefence fetch the remote URL, parse the data, and build a list that says if S number match with this S number or this one or that one or the other one. And so I got all the entries, all the 499 entries within the file. Then request will be tagged with those two tags, block list and spam house. And that means when I'm defining my ACL, I can easily go here and put spam house in the ACL, meaning whenever request match with a tag of spam house, it will be denied. More flexibility that system gives you, if you notice, I don't know, but I'm right now working on configuration for prod, and surely I can switch to stage and I can switch to test, having and using different type of configurations for each and every case, and simply allowing different configurations and different cases and different data centers to receive different versions and policies. So let's put again, within the default ACL, let's put the spam house tag and block list as an optional one and save the changes. If you notice, once I save the changes, a new version within the version history popped in because I just updated the ACL. So this is the GitOps I talked about. When I publish configuration, when I activate the configuration in a policy, I will be able to pick a specific version of the configuration in case there is a need to. More than that, suppose within my service, I would like to divide the use of or the policies for API versus UI, meaning I'd like to have a policy that will treat user-facing applications, user interface, applications that operate by users in a certain way, while services that operate with APIs, meaning accessed by servers, I'd like to have to apply for them or curate for them a different policy, right? So I will take the default entry here for the ACL, for the URL map. And what I'm going to do, I will duplicate the existing one, and I will simply call it API services. The API services, for the names, what I'm going to do, I will simply put, if there is an API within the, I would say API within the domain name, right? Then whatever comes first, if there is an API within the domain, then in that case, we would love to have a different profile for API. So I saved the application, and now I have a different, I have API service, and then I have the default entry, which will be the failover if not matching. Same time, I will do one for websites, and then in this case, I would say instead of APIs, I'll put www. So www dot whatsoever, or it can be like something, not just regular expression, rather something more specific, example.com. In that case now, I created 3 different profiles, websites, API, and so on. And that is important because it allows us to provide a very, I would say, granular, high granularity within the policies we would like to define. For example, if for the API themselves, I have two versions of the API, so I can go with v2, and that will be /API /v2, right? I'd then be able to run different policies for them while I know that we just released the version 3. So /API /v3 as a prefix within the URL would be associated with different policies, right? Now, when it comes to the separation I made here within my services, I can then attach different policies. So if you're going back to the ACL that we have had, so far we had this default ACL. I can do now, I would say, website ACL. And for the website, in addition to the spam mouse and block list I'd like to include, I also want to deny bot for all, meaning all users that accessing my website has to be verified as humans and not as bots. And at the very same time, I would like to allow Google bot, Facebook bot, right? LinkedIn, and all sort of, suppose I'm using Pingdom for monitoring, all sort of legitimate bots, which I do want to allow and not prevent access from a website. But at the same time, everything else, if it's not included within those whitelisted bots, will be denied based on, not deny as a user, simply verified. So if it's a bot, it will be denied. And that makes sense because we're talking about a website ACL. It wouldn't make sense to do it for an API ACL, because in API, some cases, API are not to be used by only humans, perhaps also by third parties and other servers. Last thing I'd like to example before, I'd like to demonstrate before we switch into question and answers, it would be the ability to control what I show in this slide, to control simply the what am I publishing to where, right? So I can simply pick a production, for example, if I'd like to test now a problem or an issue that I have in the production, I can pick the latest configuration. As you can see, all the changes I've made actually represented here are different versions. So I can go into a certain specific point of time, and instead of pushing that one to the production, I can choose to push it to my testing environment. And by that, I will simply be cloning the entire configuration from production to testing. So now engineers can test the problem, the issue, look into that, do some experimenting, and then before going back to production and making changes. Any questions so far? I think at that point of time, we should open the stage for questions.
Thank you very much, Suri. At this point, we don't have questions from the audience. So if you want to add any key takeaways from the presentation, we're happy to listen from them.
Yeah, sure. I will be happy to. So one of the rules, the foundational rules in security are you cannot protect what you cannot see, meaning telemetrics, meaning observability are key part of your security strategy. And for that, we enable carry fans to be integrated out of the box, right, of the deployment with two databases that gives you the ability to log all the events, as you can see here, Now I can see all sort of malicious activity I generated here for attacking the system, just so it will, match with, some WAF rules and ACL rules. So I'll see the system in action. And in that case, each and every request is visible by its, I would say, highest level. And then you can dive into looking into each and every detail and aspect of the request. All the tags, the system has actually tagged that request. For example, you can see here the geolocation Ireland and the effective WAF ID, the ACL ID, the name of the policies that were actually effectively dealing with this, matching with this request, and all sort of other tags the system is automatically tagged the request, metadata, all sort of timers, and ports and so on. But above all, why was this request blocked, right? You might ask yourself, why was this request blocked? And the reason is, you can see here within the URL, we got a SQL injection encoded within the URL. And when you dive in, you can see that actually that specific one, that part within the request had the SQL statement within. Therefore, the system detected that and blocked it immediately. One of the key takeaways I would like you to have from this presentation is to remember that KeyRefence is free, it's open source. Let me show you. It's free and open source, and you can basically start using it today. We are available on a GitHub, so you can go on GitHub. If you have an issue, if you have a question, if you need support, you just open a support or discussion. You can discuss with us. You can open an issue with us. And we'll be very happy to help you and assist you during your experimenting and deploying and working with this beautiful, great open source and free product. We provide documentation to get you started with, so you can also go into deployment in depth and work with different, forms of deployments, whether it's Kubernetes, using Helm or Docker Compose for experimenting, all of the policies, how to define them, how to work with them, etc., etc. So basically, I would say you can get started easily, and we will be very happy to assist and help each and every one who wants to try the product and contribute back, if possible, by providing feedback and ideas and so on. Thank you very, very much for your time and for your presence.
Thank you very much, Suri. Very interesting presentation about KeyRefence, very detailed, very articulated. Thank you very much for taking the time to share it with us.
It's a pleasure.
Appreciate it.